Good morning. Today we are going to read your fifth chapter, the periodic classification of elements. It means elements are classified into different groups to make it easy to study the properties of elements easily and conveniently. From ancient time, a number of attempts are made for the purpose that is the classification of elements. Dobereiner was the first chemist, German chemist, who proposed a law for the classification of elements known at that time. In 1829, Dobereiner's law is known as Dobereiner'S triad. Dobereiner'S triad. Dobereiner was the first scientist who established a relation between the properties of elements and their atomic masses. According to Dobereiner's triad law, when elements are arranged in the order of increasing atomic masses, the groups of three elements having similar chemical properties occur. These group of three elements are called triads. The atomic mass of the middle element is equal to the arithmetic mean of the atomic masses of other two elements of the group. It means when Dobereiner arranged the elements known at that time, he obtained a group of three elements having similar chemical properties, and Dobereiner named those groups as triads of elements. For example, first triad, the alkali metal group. In this group, lithium, sodium and potassium are placed having similar chemical properties. Here we find that lithium, potassium, sodium all are alkali metals. These all are alkali metals. These are alkali metals. All are monovalent, that is valency 1. Oxides are alkaline in nature. This group was the first triad of Dobereiner. On observing the group elements, we find here that atomic mass of sodium equal to atomic mass of lithium plus potassium by 2, that is arithmetic mean 46 by 2, that is 23 unit, which is the atomic mass of sodium here. The second triad obtained by Dobereiner is alkaline earth metals. The group of alkaline earth metals. This triad consists of calcium, strontium and barium. Calcium, strontium and barium. Atomic mass of calcium 40, strontium 88 and barium 137. Here we see that atomic mass of strontium equal to, if we find the arithmetic mean of these two metals, 40 plus 137 by 2, (88.5), which is equal to approximately equal to the atomic mass of strontium. The third triad is group of halogens. Halogens, that is chlorine, bromine and iodine. These three are called halogens. 35.75 is the atomic mass of chlorine and 80 unit is the mass of bromine and 127 is the atomic mass of iodine. Here we see that atomic mass of bromine equal to 35.5 plus 127 by 2, that is about 81.25. It is approximately equal to the atomic mass of the bromine, that is 80. Here we find that these all are nonmetals, monovalent and oxides of these are acidic in nature. The Dobereiner classified the elements known at that time into only three groups. Dobereiner was held to arrange other remaining elements according to his rule, according to his law, that is triads. But it is very important for the purpose classification of elements that it provides a pathway to study further for the classification of elements. So we can't say that Dobereiner was completely failed, but his law was not applicable for all the elements, but it has its own importance.